My name is Aidan Finn and I'm an MVP in Virtual Machine, otherwise known as Hyper-V. And I tweet on Joe Elway and I blog on aidanfinn.com, and this morning I'm going to try talk to you about the new networking features that are included in Windows 8 Hyper-V. To be quite honest, if we were able to talk about this particular topic in detail and talk non-stop, Microsoft would have to arrange hotel rooms for us all tonight, because there's a lot of content in this particular subject. So I'm an MVP in Virtual Machine for a few years now. Before that I was a config manager. I work for a distributor in Ireland, trying to convince Microsoft partners to sell more Hyper-V in System Center and Forefront. I've been working in IT since '96, worked as a consultant and a sysadmin. I've done pre-sales, I've worked in hosting, I've worked in large finance companies, and like Hans, I've done the whole virtual server thing, and I've done some of the VMware thing as well. I've done VMware in hosting and I've done Hyper-V in hosting. And my background's in server, desktop, system center, virtualization, general IT infrastructure. On the book side of things, I've worked with one of your fellow countrymen, Kenneth Van Serksen, on mastering Windows 7 deployment. I was a lead author on mastering Hyper-V deployment. And Hans drove us to announce a couple of nights ago a new book called Microsoft Private Cloud Computing. So I have a minor contribution into this. Most of the work has actually been done by Hans and two other MVPs in cloud and data management, Patrick Lowndes and Aidan Finn. This is all about how to deploy a private cloud using System Center 2012, in particular Virtual Machine Manager and App Controller. And if you want to know any more about that, Hans will be happy to answer all those questions. That's available for pre-order now, and we think it's going to be out in the end of May. So it will time nicely with estimated release at MMS. And we're guessing on the release of System Center 2012 at MMS. Nothing's official. So my warning on this particular presentation is everything in this is based on what Microsoft have announced publicly, which is pretty much what they announced at the Build conference last September in Los Angeles. It's based on the developer preview release, and a lot of the stuff that I'm talking about today, some of it actually doesn't really work yet. It will in the beta. I am told it will work. We also believe the beta is coming out at the end of February. That's what we're hearing about the desktop, and we would assume that the server will be the same. And there's a lot of stuff. I'm not going to do any demos on this because, to be quite honest, you need a lot of servers. I ordered a kit quite a while ago, and it turns out there's a shortage of hard disks. So I've got servers, I've got 10 gig networking, I've got switches, but I've got no disks. So it's not much of a lab. And so that kind of suits because we do have quite a lot of stuff to talk about here. From Nick Teaming, which was introduced to you a little while ago. And we'll go through some of the new interesting architectures that Microsoft have presented for us on the networking side of things. So, back in August of last year, myself, Hans, and Aidan Finn decided to do a survey. Find out what people were doing with Hyper-V and with Private Cloud and System Center, what people's plans were for the next release, because we had a couple of bits of information at that point about Windows 8. And one of the questions we asked about was, what are your plans for Windows Server 8 Hyper-V? Are you going to deploy it? What was really interesting was that 62% were fairly committed to upgrading from the current version of Hyper-V to the next version. Microsoft loved that. I mean, they hadn't even really started talking about the product yet, and already 62% of people were committed to doing an upgrade. 27% were interested, and only 2% weren't interested. And then we had 8% who were undecided. And at that point, all we knew about was the increased scalability of a virtual machine and Hyper-V Replica. That's all we knew about the product at that point. For me, Hyper-V Replica is one of those killer features, and it was great to see it being demoed. Nick Teaming is an interesting one. When we did the survey, nearly 28% of people said their biggest problem in Hyper-V deployments was Nick Teaming. And then another 27% said networking in general was their biggest problem. But NIC teaming I can understand because that KB article makes it very clear that Microsoft, up to now, has never supported NIC teaming. Doesn't matter what you're talking about, whether it be a file server or a Hyper-V host or a domain controller, they just do not support NIC teaming. If you wanted NIC teaming, you had to install something from your hardware manufacturer, you had to use their software, and if you had a support issue, you had to take it up with them. Now apparently there is a relationship between Microsoft and these guys for NIC teaming, but in practice, yeah, we all know what support people can be like at times. If they want to help, they'll help, and maybe sometimes communication channels aren't as clear as they should be. What I've found in my job, I'm trying to convince partners in Ireland to adopt Hyper-V, and there are a few of them, who are clinging on to VMware, and they like their rebate from VMware, and they miss the service opportunity they can get from Hyper-V and System Center, an increased service opportunity, to be quite honest. And one of the last things they're saying that, the last roadblock for them to convert to Hyper-V is NIC teaming, because it's built into VMware and it works really well. Well, that's changing. So Windows Server 8 NIC teaming, as Peter said earlier, is built in, and it is supported completely for Hyper-V. In fact, it's going to make possible some new things that we can do. So we get LBFO, or load balancing and fault tolerance. So if we want multiple network paths, we want to be able to have fault tolerance between those network paths. Windows NIC teaming will allow that. We can aggregate bandwidth. So maybe we put in 2 or 3 or 4 network cards, and we can have all of their bandwidth, basically cluster the network cards. So if we lose one, we still have maybe 3 network cards with all of their cumulative bandwidth. So we could put in 4 10 gig network cards and have 40 gig of bandwidth, and allow for one to fail, so we have 30 gig of bandwidth. And think of the amount of virtual machines you can load into that. And that's a lot of IOPS as well. We can have different model and even different vendor NICs, and that's supported. And it really does open up some opportunities. And for me, that's probably the last real objection from the VMware side, but I'm sure they'll come up with something. It's interesting because IDC say this is the last year that VMware are going to be king of the hill. Windows 8. If we look at the cumulative features, I do have a post on my website where I have listed all the features that I've been able to find that are publicly listed. There's a lot of things Microsoft are going to be doing, like the 16 terabyte VHDX. VMware is still limited to 2 terabytes with their VMDK. For me, that's a big thing because virtual hard disks are way more flexible than raw device mapping or pass-through disks. This is what the architecture of NIC team looks like. So in this architecture, they've got 3 NICs teamed. Well, that could be Broadcom, that could be Intel, that could be, yeah, here, if you're so inclined. Cumulative bandwidth, and then shoved in through. Basically, Windows is just looking at these as channels. That's the way it's looking at them. And it's just bundling them together. And then we've got our virtual switch up there at the top, and we'll talk more about that in a little while. But it's going to make some interesting things possible, which we'll get to. One of them, you're looking at this going, this is a Hyper-V talk, why is he talking about file servers? You're going to see. But when we're talking about a lot of SMB traffic, so SMB is the protocol that's used for file server traffic and communications. When we supply lots of bandwidth, or we allow a lot of SMB traffic to go through a machine, we have 2 bottlenecks with the processor, because we can start flooding the processor with interrupts and with the need to actually process the traffic. And Windows itself becomes a blocking factor for the traffic. It can increase latency for the traffic. Now there's a protocol that's been around for quite some time called Remote Direct Memory Access. And when Microsoft started talking about this at the Build conference, I went and looked for any information I could find. Now, I've mainly worked with HP hardware in the past, so I was focusing on HP. And the newest document I could find from HP on RDMA was in 2007. This thing's been around for a while, but it seems like it was widely ignored. And Microsoft have looked at it and gone, ooh, this is cool, because we can do some very, very interesting things with this. RDMA is a feature that we can get in network cards that we can turn on. And it used to be way back in 2007 that you'd buy a product key from HP by the sounds of it. I never heard of it, maybe Hans had heard of it back then. And you would type in this product key into your network configuration utility and you had RDMA. Maybe it's sitting there in our network cards now, just waiting for us to use it. I don't know. I'll find out when I get my hard disks. But the concept of RDMA is we can basically get Windows and take it out of the way. We can take the processor in our host and take it out of the way of the SMB traffic and let the network card do the bulk of the heavy lifting. And that means SMB traffic can become much more efficient. And why do we care? Well, you'll see in a little while, but one of the interesting things about this SMB 2.2, it's multi-channel, so it can take advantage of multiple network cards to do a single stream of traffic. It can take advantage of NIC teaming, it's built into Windows. We get much greater I/O speeds. It supports InfiniBand, 56 gig networking, isn't it, I think? Yeah, ridiculous. 10 gig networking cards with RDMA enabled. And it allows us to store virtual machines on file shares. Now, the first reaction I have been getting in Ireland whenever I mention that is, that will be great to store small business server. Who's going to want to put hundreds or thousands of virtual machines on that? I guarantee you, with the performance Microsoft are getting with this in the demonstrations, a lot of people will want to store hundreds and thousands of virtual machines on this. Are you talking about? Brilliant. Hans is going to talk about some very, very interesting storage options later, so I'm not going to step on his toes. But you're really going to want to do this for some storage of your virtual machines. You may want to tier your storage, and you can save a lot of money. And for those small customers, if you're working with them, or if you are one of them, you're going to have a new opportunity. But one of the interesting things is we can store virtual machines on file shares, and then we can do true live migration between non-clustered hosts if they're stored on file shares. And we have the other storage live migration option, which Peter mentioned earlier as well. And I'm sure you're probably going to talk about that in more detail. Again, great big Hyper-V survey of 2011. This was great to find out what people were doing because we just assumed. And my line about assuming is when you assume, you're wrong. Because I meet so many people who assume things like snapshots are great for backup. Yeah, I was told a story this week that I was talking to one of our customers, and he was a consultant, and he was working with one of his customers a few weeks ago, and he got a phone call from them, and they said, all our virtual machines have paused. What's wrong? And he connected to their host, and it was a small customer. Turns out they were using snapshots, Hyper-V snapshots as a backup. And they just kept right-clicking, snapshot, right-click, snapshot, right-click, snapshot. And they filled their hard disk before they reached the 50 snapshot limit. Yeah, so you encounter all sorts of strange things. One of the interesting things about Windows 8 Hyper-V is Microsoft I have the Windows 8 drinking game. So there are certain phrases Microsoft are going to, when Microsoft employees are allowed to talk about this is great being in the Microsoft building because they're not allowed to talk about the product that can't be named. It's like there's a few people in Redmond who are allowed to talk and blog about this. People here in the field, as it's called, they're not allowed to talk about Windows 8. So this is really cool that we can talk about this stuff. But one of the interesting things is that they're going to keep using phrases like optimized for the cloud and scalable and continuously available. Every time you hear one of those, you can drink one drink. I was quite drunk at Build. Every presentation. But it was interesting because they've learned a lot from Azure, as we call it on this side of the Atlantic. It's a massive public cloud. And they learned an awful lot about how cloud works and what the problems are with cloud. And of course, it's a public cloud. And they also talked to a lot of hosting companies around the world who were using Hyper-V and said, what are your concerns? What are your limitations? What's difficult? What's slow? And they worked on that. They did a lot of work on that. And big concerns for hosting companies and public cloud operators and even private cloud operators, if you're in a large enough organization to have multi-tenant private cloud, are trust issues. The hoster does not trust their customer. because their customer is doing God knows what.
Yep.
The customers don't trust each other, obviously, because they don't know each other. They need to be firewalled and separated from each other. There are compliance issues. There are regulatory issues, especially here in the European Union. We have a lot of laws about privacy and things like that. And if you're in the finance world, you're supposed to have a lot of auditing and things. I'm Irish. Sorry. So what we find is a lot of the things that we have in these multi-tenant organizations limit the features of virtualization that we value. It was interesting in the survey we found one of the big reasons people did virtualization in the first place was flexibility. Money was obviously big up there, but flexibility was also very high. And what you find is when you have a large multi-tenant organization and you're using current virtualization technologies, you are actually limited in what you can do in terms of mobility and flexibility. Networking addresses. So if I have a large data center and I have a 3-year-old virtualization environment and a 3-year-old network environment, and I want to replace that, I'm probably going to have to move my virtual workloads to another network, another footprint, and that probably requires me to readdress all those applications that are in there, new IP addresses. How many of you work with application developers? How many of them do things that are best practice? Yeah. So the cool thing we're getting is network virtualization. It's a confusing term. I wish they would come up with some other name because it's so generic in name. But the idea here is to increase mobility of virtual machines that have static IP addresses. So in this example they gave us, we had a public cloud operator who had lots of customers who were subscribing to this public cloud. And they were creating a hybrid cloud. So they had virtual machines running in their own data centers or computer rooms. And they wanted to be able to move them into the public cloud and have applications running in their own computer rooms and the hosting company's data center. But as soon as you move things, one of the things you've really got to do is re-IP address your applications. Now what if we could say, okay, you don't have to change your IP address? That would be great. But then we have a conflict because Woodgrove here is probably 192.168.1.0/24 and Contoso is probably 192.168.0/24. So if they both move without changing their IP addresses, we have a problem because they can't talk on the physical network. And anyway, this is probably 10.something.something.something. So network virtualization, the aim of it is to abstract the virtual machine's IP address. So it actually is communicating on a different IP address on the physical network and isn't even aware of it. It's able to, the virtual machines that are running in that private cloud can talk to Woodgrove's virtual machines down here and vice versa. And Contoso can do the same. So they can move their virtual machines in here and not have to change the IP addresses. And that's all taken care of by the Hyper-V administrators down here. They create, basically, it sounds like natting, to be quite honest. Be interesting to really put that under test and see how it works. So big benefit of that is mobility, not having to re-IP address workloads. If you're talking about hundreds or thousands of virtual machines, especially if they're not your virtual machines, if you're in a true cloud where you look after virtualization and management, but you have nothing to do with the application workloads, this is going to be really useful where you'll be able to move applications, you'll be able to live migrate or live storage migrate applications without having to worry about downtime. So that's really going to be useful. It's going to make it possible to do that public-private cloud integration and allow applications to be mobile between it and upgrade parts of your data center without having to worry about downtime and service level agreements of your customers. I keep hitting the volume button. So yeah, I think it's going to be a really useful feature, especially in those larger environments or those multi-tenant environments. Virtual Machine Queue is one of those features that Microsoft added support for in 2008 or 2, and it takes advantage of circuitry that's in our network cards, and it allows us to put a lot more network traffic through to our virtual machines. In some way, it's bypassing the virtual network that's in Hyper-V, but it's not completely. And it's also reducing the amount of work that's required, in theory, by the processor on the host. But it can put so much network traffic through, it can cause an increase in the amount of interrupt handling that the processor has to do. So that can be a problem, especially if you really are putting through a lot of traffic to your virtual machines. So we're taking advantage of a feature that's in network cards called Dynamic Virtual Machine Queue, or DVM-Q. You see manufacturers calling that DM or DVM-DQ and DVM-QD. So it's a typical thing, every manufacturer has their own term for the same thing. So before we VMQ, we had the static thing where the physical NIC was just working with a single core for the interrupt handling. Then we got VMQ, which is static, and it would basically just say, give me X number of cores, and it would just use them. Dynamic is more flexible. It will just change the amount of cores it needs based on the amount of interrupts or work that it has to handle to make networking work. Another feature that's in high-end network cards at the moment, these things start on the high ends, like, you know, Mercedes have talking cars after Knight Rider. And then, you know, Ford now have talking cars with their sync technology. Stuff starts at the very top end and works its way down. SRIOV is in very expensive 10 gig networking cards at the moment. I have it, I just don't have any hard disks. But without SRIOV, or single root I/O virtualization, the way our network traffic works is it comes in from the physical network card, goes into the virtual switch, which is running in user mode on the parent partition, gets filtered and routed, and then via the VM bus, which is in ring -1, goes to the virtual NIC in the virtual machine. And we have basically some latency being introduced here because we have software. No matter what you do, you've got software here being involved in what is essentially a hardware task. SRIOV removes the virtual switch completely from that. Now, we don't really have the complete nuts and bolts on this yet. That remains to be seen. We assume, hate you assuming, but we'll guess that Microsoft are going to start revealing more detailed information after the beta is released. But basically, as you can see, this has been removed. So, Carsten.
Aidan, so we would not have the advantage of the virtual switch then?
Correct. Yes, so that is a limitation. We'll come to the virtual switch, but by removing the virtual switch, we've removed some of the features of the virtual switch that we'll come to later. However, the likes of Cisco will be introducing some things that we'll get to as well. Ronald.
Do you know if this is supported for clustering as well, if you have two of them?
Yes, apparently. So, Microsoft, it's in the next slide, I think. Microsoft have announced with Windows 8 that there will be no new features that prevent live migration. So an example of this is I have a virtual machine running on a host that has one of these SRIOV capable network cards. And I want to live migrate that virtual machine to another host that has an older or simpler network card. What will happen is Hyper-V will detect that it's going to be a conflict, and it will switch the virtual machine from this configuration to this configuration, zero downtime, and then live migrate the virtual machine. So that's pretty cool. So we can start putting in newer hosts into our clusters, and we can still have live migration and flexibility and mobility with zero downtime. And that's pretty much what that slide is. More optimizations. So we're getting a thing called RSS, or receive side scaling, which basically allows us to do something similar to dynamic VMQ. In fact, it conflicts with dynamic VMQ, and we cannot enable both of these features on the same NIC. But it allows us to share network I/O across multiple processors in a host, so they can handle the interrupts. We're getting a thing called receive side coalescing, or RSC. So if we're getting a lot of packets coming into the physical network card, that's a lot of interrupts that are being sent to the processor. Receive side coalescing groups the packets and sends fewer interrupts to the processor. So the processor is doing less network processing and is able to focus more on virtual machines and the applications in the virtual machines. The last one was listed at the Build conference. They didn't tell us anything in terms of detail. It's IPsec task offload, but if you do some dinging, you'll find what IPsec task offload means to industry in general, which is basically taking IPsec processing and handing it off to a dedicated processor on a network adapter. So there's an awful lot of offloads that are available in hardware, and Windows Server 8 is taking advantage of these offloads and saying, we're not going to distract the host processor, which should be focusing on applications, because in the end, it hurts me to say this, it's all about the application. It's not about the servers and the network. Probably, yeah. The new System Center 2012 marketing. Yeah, so we'll start a System Center 2012 drinking game as well. So yeah, so that's what IPsec.TO does. So up to now with Hyper-V, if we wanted to network a virtual machine and put it on a physical network, what we would have is a NIC in the host, which is connected to the physical network. Then we create a virtual network in Hyper-V, and we connect it to the NIC. And then we connect our virtual machines to the virtual network. So it's a simple enough architecture. In Windows Server 8, as Peter mentioned, we're getting the extensible Hyper-V virtual switch. I've also seen it called the Hyper-V extensible virtual switch, but extensible is the key word, and switch is another key word. It is a true switch with ports and the whole thing. It can be managed. It can be extended by third parties. One of the interesting things from my experience working in hosting was that whenever something went wrong, it was usually something on the network side of things. And our network guys were able to troubleshoot and log all of the physical side, but once packets entered Hyper-V, they weren't able to do any more tracing. And it was an awful lot of guessing and figuring out and trying to understand, okay, how does networking work in Hyper-V? And as you can imagine, it would be time consuming.
I have a small question, and maybe it's not a smart question, but I ask it anyway. If we are moving off all the different tasks to the hardware of the network adapter, do we get any tools in Windows Server 8 where we can see what is if there is a bottleneck or a latency on the hardware side of the network card? You can see it on your CPU taking resources, but you don't know when your network card is getting filled up.
That's a great question. Ronald, have you any experience with that?
No, but it seems a good suggestion as well.
Yeah. Let's remember that one. That's a very good question and suggestion, and we will take that and we will feed it back to the Hyper-V guys if we can't find anything. It's a great thing about the Hyper-V guys is when I said things are subject to change, with the Hyper-V guys they really are, because once the beta opens and there is a place on Connect where you can give feedback, they take it very, very seriously. And things do change when you're dealing with the Hyper-V group. And we are witness to that. We can't talk about it in detail, but we are witness to it. And so if we can't find anything, and if we do find something, you guys will probably blog it. So keep an eye on the Hyper-V.NU site. A couple of extra hits.
Can I just throw in, just following on from your kind of high-end stuff, we've seen some tools from vendors for things like InfiniBand,
Yeah.
to monitor what's going on with InfiniBand interfaces, so it's probably logical that it will filter down to...
Well, it's quite possible when I get to my next slide that some third parties will also offer some things. Because remember that I did say this was an extensible Hyper-V switch. And the extensibility, so it's certified extension, so this means it's going to have to be tested and approved. And so we can start injecting different features into this switch for monitoring and figuring out what's actually going on. And even handle or changing the way the switch works and making it more manageable in an existing physical network. So these are some of the partners who've announced products. Cisco, if you go onto their site, you will actually see the two products that they have announced. I've seen one of them in action at the Build conference. They basically converted the Hyper-V virtual switch into a Cisco switch. And they were able to manage it from the same tool that they would use to manage a physical switching network. Now for a network administrator, that's great news. And that probably means as well that they're going to be able to do all the same level of monitoring that they could do with Cisco physical switches. Also, don't forget System Center Operations Manager 2012, or whatever it's called these days. Is it System Center 2012 Operations Manager? Operations Manager System Center 2012. 2012 Operations System Center Manager.
You'll figure it out sometime.
Ops Manager. And because it has baked in network monitoring as well. And it will be interesting to see how the Hyper-V management pack works with Operations Manager 2012 System Center, or whatever it's called. Like NEC apparently have announced that they've apparently got some open source switching, and they're going to inject their functionality into it as well, if you want. So there's all sorts of crazy things you're going to be able to do. I think Inmon, by the sounds of it, are doing monitoring stuff. I don't know. To be honest, I fell asleep during their presentation because I was jet lagged. But yeah, there's some very cool things happening. So that argument about, oh, VMware, we've got more partners. Yeah, these are kind of the guys you really are concerned about if you're in a big network where you are doing this extensibility stuff. So, and to be quite honest, there's more partners than Microsoft. So, continuing with cloud and security things, we asked people about what they were going to do with private cloud and what their concerns were. The biggest concern by far seemed to be security in the private cloud. Over 42%. And as I said, you just can't trust the tenants, and the tenants can't trust each other. It's a big thing. And that was feedback Microsoft got from the hosting companies. And they actually quoted a hosting company from Europe on that one. Someone I happen to know very, very personally, because I see him shaving most mornings. But the way we've been trying to do security with Hyper-V up to now is taking advantage of the physical network. We've been using the firewall. When you have this large multi-tenant environment and you're creating firewall rules for each customer, if you're I see the reaction up there. It's got to be nasty. I can tell you it is nasty, because the more tenants you put into that, the more complex the firewall rules get, and the more scared the firewall administrators get. Because it just seems to me that that stuff becomes more unstable the more complex you make it. And you're starting to introduce and bake in all sorts of complexities that they can't really be scientific and sure about. It gets very, very complicated. It requires specialist skills. And it also means if you're deploying new workloads, private cloud is all about deploying workloads and applications very, very quickly. It's about the end user, the developer, or the application administrator, doing that for themselves through virtual machine manager or app controller, or requesting it through service manager. If you have to introduce a firewall administrator to that equation, you've gotten rid of one of the big benefits of the private cloud. You slowed things down. We're also trying to use VLANs. VLANs were never intended for security. They were intended for dealing with address issues and dealing with broadcast domains and all that sort of thing. And also, a physical network has a limit on how many VLANs it can support. Now, if you are doing a large hosting public cloud, or if you are in a large government organization doing a private cloud, you're going to run out of VLANs. And that's going to be an issue. So Microsoft's solution is to take the security problem and solve it with software, because software is quick, it can be automated. And we can remove the need for those dedicated physical firewall skills. Let them manage the edge network. That's their strength. So we're getting portacles or access control lists. And this allows us to define what communications are allowed between virtual machines. And that will use IP addresses or MAC addresses. So we can start automating that if we want. Maybe we can put in default rules. We're getting private VLANs. Private VLANs are something that exists already in industry, and Hyper-V is adopting those. So it's like a VLAN. Microsoft call it a domain, I've seen in some slides. I wish they would not call it a domain, because we've got lots of complications with like the word snapshot. I think there's 4 or 5 different types of snapshot in Microsoft technology, and it's confusing people. It's why people are doing Hyper-V snapshots for backup, because they've heard of VSS snapshots and they confuse them. We're also getting DHCP guard. Remember I said you can't trust your tenant? I once had a situation where I was an administrator, and about 12 o'clock in the day, a call came in from the end users, and it started coming in more and more and more and more. People not able to get on the network, and not being able to access file servers and SharePoint and various different things. And what happened was, a security researcher had decided he needed to research something about DHCP, and he brought up a DHCP server on the network. Now, if you did the Active Directory or the networking exams, you've been told, well, a DHCP server can only work if it's authorized. If it's a domain member. And the security researcher, who was my cousin, actually came close. Eventually, one of the network guys tracked down where the bootp traffic was coming from and going to, and we isolated the port on the floor. We knew where the port was, and was like, oh no. And so we had to have a conversation with him about that. And the same thing is very possible in a multi-tenant environment. A lot of hosting companies, have you heard the term VPS? Virtual Private Server. Very often what they do is they have one big flat VLAN with a lot of public IP addresses, and they just put lots of customers onto that one flat VLAN, and they'll use a software firewall maybe to block them, maybe not. Maybe you've used a server operating system firewall. But it's very possible for someone just to bring up a DHCP server. There's no way to stop that really. Once you're a server admin, you can do what you want with the server. So what DHCP guard does, it allows Hyper-V administrators to block DHCP traffic. And it stops that rogue DHCP from affecting the network. Yes, they can still enable DHCP on their servers, but they can't allocate or communicate on the network. And that is a pretty effective solution. On the performance side of things, performance is very important in a cloud where you're a service operator, be it public or private. When this whole transition into private cloud, that's another one for the System Center 2012 drinking game, transitioning to the private cloud or transforming your IT. The journey. Service level agreement is a big thing because you become a service provider and your users are now your customers. I suppose that's better because, as Mark Manassi jokes, what other industry calls its customers users? It's usually Colombian. So, NIC teaming allows us to aggregate bandwidth. So you could aggregate lots of 1 gig NICs, pretty cheap way. Aggregate lots of 10 or a couple of 10 gig NICs. 10 gig is pretty expensive at the moment, but that will probably come down. In Ireland, a Netgear 10 gig switch costs between 6,000 and 8,000 euros. Netgear. Yeah. So, having worked in the hosting world for a few years, I can tell you if you give someone bandwidth, they will use it. They will take every advantage of it. They will work on their movie and MP3 library like you would never believe. Of course, SOPA will solve all that. But we want to be able to guarantee SLA for real applications. So we want to prioritize applications. Maybe we want to limit our tenants based on how much they've paid us. So in the hosting industry, this is an important one. A customer who pays 50 euros a month might get a meg of bandwidth. A customer who pays 1,000 a month might get a gig. We want to be able to guarantee those SLAs. So if someone is paying for a certain amount of bandwidth, we want to be able to make sure that they get it. And maybe we want to allow to burst beyond that. Right now, that's physical networking. The physical network has to do that. What about inside of the virtual environment? The physical network can't help us with that at the moment. That's where QoS comes in. So that's being added in Windows 8 as well. And it's one of those things that right now is completely managed through PowerShell and is not revealed in the GUI. So Jeff's going to have an awful lot of PowerShell blogging coming up, I reckon. So QoS, as I said, is configured using PowerShell. And we have two basic policies, minimum and maximum. Microsoft think the one we're most going to use is minimum, because it allows you to say you are guaranteed X meg of bandwidth. And if there's anything free, you'll be allowed to burst up to that free amount and take it as you need. It allows you to make more efficient use of your bandwidth, and as I said, redistribute free bandwidth to those people who need it. The maximum policy is probably the one that the hosting companies are going to look at for their public clouds. And this is where you can limit how much bandwidth and how much impact a customer can have. Maybe you have this one, you have one bad person who does like BitTorrent, and you can put in this one to block them or limit their effectiveness. I find when I'm downloading CentOS and other things via BitTorrent in hotels, but this one seems to be in place for BitTorrent traffic. Not that I'd be downloading anything else. And we can combine these policies as well with network resource metering. Resource metering is a cool new thing that's being added. It allows us to measure network, CPU, and disk utilization of virtual machines, and then take that information and charge the customers if we want. The information is stored with the virtual machine, so it moves back and forth with the virtual machine. It means we don't need a database to store this data. Now right now, it's limited to being queried by WMI and PowerShell. Microsoft's intention is that third parties and maybe System Center would query this and allow us to create reports if we want. It was interesting when I was at a competitor's private cloud event in Dublin last summer. They were talking about their ability to meter, and they said very few of their customers really wanted to cross-charge. However, their IT people wanted to show the work they were doing and what they were making possible and the value of their work, and that's why they were using resource metering. So I think that will actually be useful to people, even if they don't have cross-charging in place. If we look at a current cluster, if we look at a host, the minimum recommendation NICs is 6 if you're doing iSCSI. If you're doing NIC teaming, you're going to need more. So you've got your parent, virtual machine, redirected I/O or CSV net private network, a live migration private network, and then 2 iSCSI NICs connected with MPIO. If you're NIC teaming, you're going to need more. If you're doing a large environment, you probably need a dedicated backup NIC. Again, if you're doing a large environment, you may have fault-tolerant NICs for this. I know that's a recommendation that Microsoft Premier Field Engineering typically give to their customers with large clusters, is put in an extra private network to handle these things. Lots of NICs, lots of switch ports, lots of money. Be very expensive. And if you are dealing with large hosts, this will probably be 10 gig. If you're doing VDI, good chance that's 10 gig, unless you're doing fiber channel. Your VM could be 10 gig as well. Your backup, if it's large, will have to be 10 gig because there's a lot of stuff to go back and forth. So the basic implementation with Windows 8 to replicate that looks kind of like this. So the images I'm presenting from now on are from the build conference and some of the architectures that they showed. We don't have firm, this is what you must do yet. That's going to come later in the process. But this was the first, they're calling it physical isolation. So we have a live migration network, we have cluster and storage, and we have management. You're doing direct I/O, are you? CSV? No? Okay, so I won't talk about that. And we have our Hyper-V extensible switch. Now we haven't done any NIC teaming or anything. This is a basic physical isolation process. We can put in access control lists or port handles here to limit how virtual machines can communicate with each other on the network. Another new thing we're getting is data center bridging, or DCB. And what DCB allows us to do is take different classes of protocols, very different alien protocols, like iSCSI and virtual machine LAN traffic, and effectively and efficiently put them on the same NIC. Right now we should be physically isolating them, And your storage vendor will be saying you must physically isolate them. But DCB is going to change what we can do. And it's going to allow us to do something called converged fabrics. A fabric is a network. So we have a storage fabric, the SAN. We have our networking fabric, where virtual machines can talk on the physical network. And you're deploying those probably automatically if you're using Virtual Machine Manager 2012 and later. Converged fabrics is a new possibility, unless you're doing HP blades and Flex 10 and stuff like that. But Flex 10 is very, very expensive. Virtual Connects in America are $18,000, I think, each, around the same year. Yeah? Two. Yeah, you've always got to put them in pairs. You have a limit on how many NICs you can create on them as well. Yeah. So, very expensive hardware, but very good hardware. Won't criticize HP on that. Converged Fabrics is a software solution for doing the same thing. So we can take advantage of having big network cards like 10 gig and put in fewer of them and use fewer switch ports. And we can give lots of bandwidth to our virtual machines and our various different pieces in the host as they need it by taking advantage of things like QoS. And we can use DCB to get those alien protocols like iSCSI and LAN traffic and put them on the same NICs. And there's a lot of variations by using all these technologies, don't forget teaming. By using them together and juggling them, we can get a lot of different architectures. So, taking the previous example, the physical isolation, we can switch it to this with 2 NICs. So this could be 1 gig or 10 gig depending on our assessment. Hopefully you are doing map assessments for sizing your hosts. And our virtual machines, Hyper-V extensible switch, talking on 1 physical NIC. And then we can take our management, our parent communications, cluster storage and live migration, and put them on 1 physical NIC, taking advantage of DCB. We might put in QoS as well to limit or guarantee bandwidth for each of these protocols. So if this is a 10 gig NIC, I might guarantee 4 gig to live migration. I might guarantee 4 gig to the cluster, but I will allow them to burst to whatever is available to take advantage of that 10 gig pipe. Next one is where we're introducing some optimizations. So dynamic virtual machine queue to allow greater throughput and reduce latency of virtual machine traffic. And receive side scaling, which is mutually exclusive to V&Q. And optimize how the processor optimizes interrupts for these functions on the host. I can introduce 10 gig and have everything go through the virtual switch. If you've been working on vSphere, there's a good chance that this looks kind of familiar. So we've got live migration, cluster storage, management, all going through the virtual switch. This is a first for Hyper-V, because we've always had to go put these direct through a NIC. It's a very interesting architecture, 1 NIC. But there's a good chance you're buying servers that have 2 or more NICs. If you're buying HP blades, the built-in NIC is 2 10 gig NICs or 2 1 gig NICs. So maybe you want to do that. So if you're buying a 10 gig NIC, it's probably got 2 ports.
How do you do with that in a current environment when you build
Flex 10 hardware functionality is how you do it with 2008 or 2.
And if you use 19-inch models, do you place like 6 10 gigabyte NICs?
No, in this I've got 2 10 gig NICs. For existing
For
thing,
current existing.
you talk to your hardware manufacturer. It's great how often I can put off an answer with talk to your hardware manufacturer. I did a bunch of events on Hyper-V in Dublin at the end of last year, and the regular answer was talk to your storage vendor. It's great, that one, because they all have different recommendations and requirements. But what NICs you can put in your server is your server manufacturer. So HP, I would say, look at the quick specs. And that will tell you what extensibility you can put into your physical tin. And if you want to learn about 10 gig networking on current versions of Windows, have a look for Working Hard in IT, Didier Van Hoy. He has done some brilliant blogging and research on that particular topic. And he's an MVP now, thanks to that work, because he was the only one that was really doing it. And I should say 10 gig networking in Windows 2008 or 2 is built to take full advantage of it, and InfiniBand. But this particular example, we've teamed the 2 NICs, we're aggregating their bandwidth. Maybe I could put in another 2 and treat it like a cluster. So I have 4 NICs, but I could guarantee 3 NICs if they're all on different switches. So I could say I could have 30 gig of guaranteed bandwidth. Then into the switch, using QoS then to guarantee a certain amount of bandwidth or to limit bandwidth to each of these functions. 2 NICs, I can do some seriously clever stuff with this architecture. It's very flexible, very clever. I am going to step on Hans' toes a tiny bit with this one, but not too much, it won't hurt. So we've taken that particular example on this side, and we've got 2 1 gig NICs teamed, virtual machines talking on that. But then, for my host fabric, I've got 2 10 gig NICs. I've got data center bridging, so I've got my different classes of protocols all effectively working. I've got receive side scaling to optimize how the processor handles the interrupts. I've got QoS to guarantee SLA for the networking functions, and I'm putting parent, storage, and live migration through a NIC team through those 10 gig NICs. And with the assistance of RDNA, I'm storing my virtual machines on a file server. So this is one of the documented architectures that they showed us. And so with 4 NICs in my host, I've got a very clever architecture here, and I've physically isolated my virtual machines from my host architecture. So some people will want that physical isolation, even though we could have, in theory, merged those 2 different fabrics. There's a lot of material. I don't know how I've been on time, but there's a lot of material on the networking
15 minutes
side.
left, Aidan.
15?
15.
Oh, cool. Hans, you plenty of time. So there's a lot of material on the networking side of things that was presented at the Build conference. If you go onto that URL or do a Bing for Channel 9 Build, you will find that particular URL. And then if you scroll down on the right hand side, pick the networking option, you'll find these particular presentations. You can download the slide decks, you can download or watch online the videos, and get the material firsthand from the Microsoft folks. So there was particular presentations on Hyper-V, there was presentations on networking, there was presentations on networking and cloud computing, and then there were presentations on storage and lots of other cool things like Windows to Go if you want to try this out by running Hyper-V from a USB 3 stick. So that's the end of my presentation.
Yeah. Maybe if I can ask if there are any questions.
Yes.
So,
Are there any more questions? From the man who looks like Toby.
Who is not Toby? One question. We were talking about teaming, NIC teaming. What kind of technique are we using for NIC teaming? Is that the 802.11ad NIC
Great
teaming,
question. I am not sure. Do you know?
Well, half the vendor depends. The teaming software from your vendor depends which
kind of
options are available.
LACP or vendor
Well,
specific?
the teaming which works most without any problems is the active standby kind of teaming,
Yeah,
that doesn't load balance.
Sure.
And all the other ones depend either on the switch or
it depends on the driver.
it depends on the driver and your vendor.
Your
Yeah.
switch configuration, whether you're doing
The
stacking and not and stuff like that.
Yeah.
The LACP is like a standard for that? Is that
So
supported
it's
as well?
supported in some vendors teaming software.
And depends on the driver.
It's not supported with Rex
Okay, so
Extend, by the way.
No.
So I have to say that I really don't use teaming because I hate it. And because it does introduce complication on the support. So any Hyper-V I've done in the past, I have not done NIC teaming.
You should read.
However, I will change it. And if you want to know about NIC teaming in the HP world, Hans' blog posts, he's got loads of it. Ronald.
I have a question on best practices, even though they may not exist yet. But very often you hear people say if they have issues with networking, then one of the first troubleshooting steps is, well, let's disable all the offloading. Is that still the attitude, or is it changing to...
So in 2008 or 2 it still is. I've seen like Premier guys in action and MCS in action where they would go, yeah, disable this, disable that, disable the other. Because there's a reliance with the driver. And and you don't know how good the driver is. So by disabling certain pieces, and it's not just the driver, it's also the firmware on the hardware. And I would say that's probably going to continue, that if you do find a problem. But we haven't really heard that yet. That's probably something when we get to RTM time, we'll probably have information on that.
I think it's a bit the same. Do you think it will be reliable, the network part?
Yes.
Because all the Hyper-V part of it are developments of existing things.
So
and Microsoft's reputation in networking components is not that good.
I will say that Microsoft actually do a good job. Where the trouble can be is in the drivers. And Hans had a great recommendation. I heard him talking about it last year when we had a Q&A session that I can't talk about. And Hans basically said, treat your hosts like a mainframe. When you find stable drivers, don't upgrade them for the sake of upgrading them. Once you're on stable drivers, stay on those stable drivers. Only upgrade if the hardware manufacturer, if you have a support call and they say you must upgrade then.
Check the HCL.
Yeah, so you've always got compatibility matrices as well.
You have things like RSS, and then you enabled it because it was a cool feature, and after
test.
Networking stuff.
Don't just introduce something new on a production environment. Test it. Make sure it works. If there is an issue, find out where the issue is, and use your support mechanisms, because it should be working. You've paid for hardware, you've paid for drivers, you've paid for software. The stuff should work. Take advantage of the support mechanisms, get it fixed for yourself and for the rest of us. Jeff?
Well, with server 8 you can create two environments, production and test. Make the configuration change on test and live migrate your production.
Well, if it's the host configuration, you can't really do that, but virtual machines could.
Yeah.
Yeah.
You said that VLANs are not required because of the private networks, private domains.
No, I didn't say that.
Will replace
It's still.
How does it correlate? I assume that multiple hosts will share the domain or networks.
They'll share the configuration.
Correlate to the physical domain. Will it also onboard a routing engine?
Tell you what, when I've got hard disks and I have my experience, I'll blog about it and maybe I'll write a book. I honestly don't have the answer for you, to be quite honest. And when I have the environment and I can test that properly, we'll be sharing the information. I'm sure lots of us will be sharing the information because there'll be a field day of activity once the beta's out and we've got a bit more firmness about what things are going to be and how they're going to behave and how they're going to look. Because developer preview is exactly that. It's not intended for us. It's intended for app developers to start coding apps to sell on the Windows Store when it launches the end of next month. There's another question.
You touched a little bit about the current situation, if you want to do it now with Blade Chassis and FlexTen.
Yeah.
Cisco introduced Nexus for the Blade Chassis. Does anyone have experience with that? And how would
I don't have hands-on experience, but I know a company in Northern Ireland who does a lot with UCS. It's their favourite server.
Yeah.
And they rave about it.
Okay, but inside the HP Blade Chassis.
Oh.
The Nexus switch.
That I don't know. Yeah, I heard they'd released, they'd made friends again. Okay. I honestly can't say. If you haven't, who has?
Yeah, that's my biggest question. Nothing. So it's Windows 8.
So if anybody's done anything with Nexus on HP Blade Chassis, talk to this man here.
There's a guy in Oostenrijk called Maurer, I think, Thomas Maurer, and he's blogging on the Cisco stuff a lot. Yeah.
The new feature of putting your VHDs on the file server.
Yes.
Why would you do that?
Cheaper storage. Much cheaper storage. And also another advantage of it is hosting companies do not like building virtualization clusters because that fault tolerance is something that has to be charged for. And a lot of hosting companies do not cluster their virtualization hosts, they build standalone hosts. And if they can put the virtual machines on a file share and then permission that file share so the hosts can read and write to it, they can live migrate virtual machines between the hosts without having to do a live storage migration. So it's just it's just a memory that has to get copied over a 1 gig network.
Yeah.
So it's a very cheap, effective way of doing virtual machines and shared storage. So the large enterprise will probably continue to do, the high-end SANs from the likes of HP and EMC and so on and so forth, and NetApp obviously. Because there are some very, very big online operators using NetApp. And we have a very distinguished NetApp person in the room, who is actually very good to us in the community. But yeah, people want the option, they want choice. So it's not just something for the small business who could put in a single file server. You can also do some very clever stuff that Hans will talk about. You are talking about that, aren't you? That the enterprise is going to be very interested in because it's a cheaper way to have shared storage that's scalable and continuously available. Hit the bars twice. So yeah, it's choice, it's options, and people will probably, dip their toe in the water and be skeptical. But in the demonstrations we've seen and some of the information the very limited amount of information is put out there publicly, they're getting ridiculous throughput in this stuff. They're able to match, iSCSI on the same sort of networks because they're taking advantage of SMP 2.2, NIC teaming, and or DNA. So they are getting great performance, and they are saying this thing will be very scalable as well. But the fiber channel SAN still is the ideal solution, but not everyone can afford it, and not every application does need to be on that type of storage. And there are other offloads that Hans is probably going to talk about as well that type of storage can do that file servers can't.
Right, thank you.
But Hans will probably talk a lot more about that, and he's done a lot more research on that topic. We've kind of divvied up the workload for this one. Anyone else?
Yeah. Is there a Hyper-V calculator for
No. No. I would presume it's a safe bet that there'll be a new version of MAP to take advantage of the new things that Windows 8 can do. So it's fairly safe bet that we'll see a new version of MAP appear in beta in a few months' time. Once Windows itself has gotten into a fairly locked-in point around release candidate, it's a good chance we'll see the MAP beta turn up then that takes advantage of these different features and helps us do our sizing. And there's already IOPS stuff in MAP anyway. It's a bit crude, especially if you're dealing with multiple CSVs or whatever. It's a bit crude, but there is something there already. Peter?
Well, Aidan, thank you very much.
No problem.